And so, let me start with the formula, all right? So the book says, look, I've got an alpha particle that has a mass of 4. It's not moving, it's sitting still. I have a proton particle that has a mass of m. Now, truthfully, they have numbers, but the numbers would complicate things, right? The alpha particle is usually 2 neutrons and 2 protons that just kind of hang out together. And what it says is they have a head-on collision. Well, if this is sitting still, the head-on collision looks like this. The proton hits this thing head-on. Now, if it's a head-on elastic collision, that means they do not stick. So once it hits, there's a possibility that the proton goes in this direction and the alpha particle goes this way. There's a chance that once they collide, if the math works, this one will move and this one will move. So we might have 2 velocities going in this direction. And they want us to figure out what the 2 velocities are. Well, this is a conservation of momentum. And that means that the initial momentum should equal the final momentum. Okay? So, here's the thing. I have a whole bunch of variables there. And we have 2 unknowns. What are the unknowns? I don't know the velocity of the proton, and I don't know the velocity of the alpha particle. So I got to solve those. Right? So really what I'm looking for is what is this and what is this? So in order to do that, I need to solve the equation for 2 unknowns. Now to solve that equation would take a little bit of time, and I might lose you guys in the process. So if you turn in your book to page 212, they've kind of went through that process and they said, hey, look, if you have a head-on elastic collision, and these are formulas 6.14 and 6.15, then the velocity of the object number 1 is equal to the mass of the first object minus the mass of the second object. In other words, think of this in terms of this is object number 1 and this is object number 2. So this will have a mass 1 initial and a velocity 1 initial, and this will have a mass 1. Well, we don't need to write the initial because the mass doesn't change. And then it'll just have a mass 1 and a velocity 1. And this one will have mass sub 2, velocity 2 initial, and this will be mass 2, velocity 2 final. Okay? And so that's where these formulas come from. So V sub 1 is equal to this stuff. And then the final velocity 2 is equal to this stuff. Oh, I didn't finish writing everything down. So let me make some room here. I didn't write everything down. This plus 2m2 all over m1 plus m2 v2 naught. Okay? And then this one will be minus, this is times the initial velocity of the first object plus, I keep writing the wrong thing down, minus m1 minus m2 all over m1 plus m2 v2 naught. Okay? So now what they did, this is the final velocity for the second object. This is the final velocity for the first object. So now if we go back, what they did is, because we have two unknowns, I need to represent this information in two separate equations. And then what will happen is we can plug all the information in, and then some stuff will cancel out, and hopefully we can get the velocity for one and the velocity for the other. So the problem's kind of rigged up. So they've taken these equations and algebraically manipulated them to get these two equations. Now the only thing that we need to do differently is start plugging some stuff in. So technically, if I take this stuff and apply it to our problem, I'm going to get that the velocity of the proton is equal to the mass of the proton minus the mass of the alpha particle all over the mass of the proton plus the mass of the alpha particle, right, times the final or the initial velocity of the proton. And then the second half of that equation kind of cancels out, right? Now, why does it cancel out? Let's look and see. See this second half is the velocity, the initial velocity of the alpha particle, right? Which is what? 0. So, because it's 0, this whole thing kind of cancels out. So that's how we're able to get this. Okay? So now let's solve that. What is the mass of the proton? Do you guys remember?
M.
It was just m. What is the mass of the alpha particle?
4m.
4m. And then what was the mass of the proton again? M plus 4m, right? Times the initial velocity, which was 3 times 10 to the positive 6 meters per second, right? And there's some kilograms and stuff, but you'll see that the kilograms cancel. So what is m minus 4m?
Negative 3m.
Negative 3m. What's m plus 4m?
5m.
5m. And there's some kilograms, right? We've got like kilograms on the top, kilograms on the top. Times this 3 times 10 to the 6 meters per second, right? All right. So when I tried to show you guys this before, I was trying to show you that we would get to this point. But the problem was that the algebra was a little intense, and when I did all the subset notation, as I kept explaining each step, you started to do this. So anyways, maybe I'll show you that a different day. So this stuff cancels. And I really get negative 3 over 5 times the quantity, 3 times 10 to the 6 meters per second, right? Now, if you plug that in your calculator, what do you get? Well, this is actually 0.6, isn't it? Well, it's a negative 0.6 times the 3 times 10 to the positive 6 meters per second. And so that gives you a negative 1.8 times 10 to the 6 meters per second. So that's the, what was that, the final velocity of the proton, right? Now, does anybody have any questions? Do you kind of understand what I did there? And even though we didn't finish the derivation, could you see what Mr. Adams was starting to do? I was starting to move all that stuff around so that it would look like this. Right? I was trying to make it look like this, and we would have gotten there, but I think it was just too lengthy for you guys, okay? So we go through, and that second half dropped out, and we plugged everything in, and we got an answer of negative 1.8 times 10 to the 6. Now, how many of you guys were able to get that on your calculator? Raise your hand. Did you guys try it? No problems? Okay, good. You guys, now probably on your calculator, instead, it might have looked like this. It might have said negative 1.8 e to the 6. Is that how it showed up? You guys know that means the same thing, right? Okay, good.
Yeah. I got negative 18. like negative 1,800,000. So I didn't get the shortened version.
Oh, you got the full. What he's saying is it didn't raise. He got the full. You know, if you multiply this by 10 to the 6, it's like 1,800,000 or something like that. So he got the full blown thing. That's just a setting on your calculator. All right, but it was equivalent to this, right? Okay, good. All right, so now let's do the second part. So now to do the second part, we still need to know the alpha particle. Okay, so now the alpha particle. Remember, we had to use this equation. Whoops, got a little ahead of myself. So this represented the proton, and we'll list it at the end. Now we need to do the alpha particle. So technically this is the alpha particle, right? So technically this thing here is the alpha particle, the final velocity. Well, again, this is based on the initial velocity of the second particle, which we know is 0. 0 times all this stuff is 0. How convenient. It worked out. So I only really need to focus on this stuff, right? Except I'm going to change M1 to P, and then this is going to become alpha, and this will be the proton. So if I come back here, the final velocity for the alpha particle is going to be a little easier, and I have it written down so I don't make a mistake here. That's just going to be 2 MP over MP minus M alpha sub alpha times the velocity of the proton, the initial proton. So now when I'm saying, I'm trying to go as fast as I can so it doesn't take too long and you get bored. Yes?
Isn't the bottom you add it?
Do you add it on the bottom? I think you're correct, yeah. I'm trying to, because it takes so long, I'm trying to hold your attention by going quickly. But I need to make sure that you understand what this is. Tell me what this is. Mass of the proton, right? Tell me what this is. Exact same thing, right? Okay, what's this? Mass of the alpha particle. What's this? Which velocity? The initial. How do we know it's the initial? Yeah, it's subset 0, but we always pronounce it not, right? And then what's this? Final velocity of the alpha particle. Good. So let's plug those in. So that becomes, what was the mass of the proton? Just m, right? And then so this will be m plus, what was the mass of the alpha particle? 4m. It's literally 4 times because you got 4 of the same thing. A neutron, the mass of a neutron is very similar to the mass of the proton, and so in this particular case, we're just going to neglect the differences, right? We're just going to ignore it. And so then what was this? 3 times 10 to the 6 meters per second. And so here we get 2 over 5 times 3 times 10 to the 6 meters per second. This is the same as 0.4 times 3 times 10 to the 6th meters per second, which is the same as, I don't need a calculator for this one. How many of you guys got the same answer? What I learned is if I have this proton here and this alpha particle, and if this proton approaches this way at 3 times 10 to the 6 meters per second, and this one here has an initial velocity of 0 meters per second, right? And I'm going to move it over here a little bit. If this thing's chugging along at 3 times 10 to the 6 and it hits this, and it's an elastic collision, head on, then this will move, and this will move, and which way does this one move though?
Left.
It's going to go this way, right? And that's going to have a final velocity of negative 1.8 times 10 to the 6 meters per second. This one's going to move this way with a velocity of 1.2 times 10 to the 6 meters per second.